Today on the MotoMan Podcast, we learn that the future of Italian exotics didn't start in Modena or Sant'Agata Bolognese. Rather, they started in Oxford, England.
Our first serious automotive customer was Koenigsegg. Koenigsegg only needed a couple of hundred motors, but even that was a vital stepping stone in just, going from the hundreds, then into the thousands, then the tens of thousands, and the hundreds of thousands.
And you won't be surprised to learn that got a lot of attention.
Mercedes approached us, we didn't approach them.
And just recently, the debut of the first visible fruits of that acquisition took the form of an entirely new type of AMG.
This technology you're seeing today is 2 generations old.
Translated, the real story is what's coming next.
The power density of the product is getting to absolutely eye-watering stages.
So with that, remember that really smart kid back in school? Well, we catch up with what he's doing today. YASA founder and CTO, Dr. Tim Woolmer. So what was it, 3 months ago? Before you and I get too far down the road into today's episode, I want to share a little bit behind the scenes about what you're going to see. You've now experienced 10 of our reimagined MotoMan Podcast episodes, which have all been shot with our new state-of-the-art Sony Cinema Line gear. However, before we acquired that gear, we did shoot 10 episodes of the podcast with the old gear. We're calling those the Vault episodes. What does that mean for you today? The picture quality, it may not be to the level to which you've become accustomed. However, the audio, the post-production, and absolutely the storytelling is all the same. So while you watch this discussion between me and an amazing guest, I will continue on the top end of this, a bicycle with a Volkswagen motor strapped to it. I was in San Diego at the design studio for Mercedes, and I was there to see Gordon, to interview Gordon.
Mm-hmm.
And I was focusing only on that. And then after that, I was there to shoot 2 cars, first drive review. They had these workshops, and I couldn't care less about the workshops. It's like, we got this thing here with this design thing, and we got this like technology, which was putting on VR glasses, which had nothing to do with my audience right now. So I'm kind of floating around. I'm walking from workshop to workshop, and then I see this guy with this British accent, and he's got this pancake. And I stopped and listened, and the ball dropped. So I want you to recreate that moment for the audience. Explain, to start from being, what exactly is this pancake?
Well, thanks for having me on your show. So I think YASA is a company that was founded in 2009. So we've been going for, quite a few years now. And the company was started on the premise that electric vehicles were coming. And we wanted to make an electric motor that was a good fit, perfect for the electric vehicle market. So, and this work was founded on a PhD that I did back in 2006. And the target was to make something lighter and smaller and efficient, something that we could manufacture at low cost. Because up until that point, 99.9% of the electric motors used in cars were radial motors. So if you looked...
and what is that for the uninitiated? What is a radial?
Yeah, so a radial motor is one where you have the rotating part, the rotor in the center, and on the outside you have the stator, and the flux travels radially, and hence the name radial flux. And my PhD really took the initiative to look at, well, are there any other topologies, any other types of motors that could reduce weight, in particular, improve efficiency? And so this led to an interest in axial flux motors. They're sometimes called pancake motors because they're very axially narrow. Now, the nice bit of serendipity or good fortune was very near the start of my PhD, stumbled into this fascinating topology or type of axial flux motor we called it the YASA topology, which basically stands for yokeless and segmented armature. And you can kind of see that here, that this is the stator, and the stator is split into a series of segments, and there is no big armature holding it together, which is what you get on radial machines. Now the beauty of this is, I mean, you can pick this up.
I was blown away at the
This
weight.
is 250 horsepower, 5 kilo stator. If you were to do the same with the Radial machine, you'd be picking up something that was more like 30 or 40 kilos.
It would probably land it on my foot.
It would not sit comfortably on this table. So now this is obviously the result of a lot of development on this topology. The very first ones we made were probably 10 times less power dense. So we took a topology that had a huge amount of potential. And actually the work on my PhD showed that we should, if we do a good job, we should be 3 times better than a Radial machine. If you just look at the materials required without the yoke, with the cooling that we use, the physics says we should be 3 times better than a Radial
So
machine.
let's stop there, because I mean, you collect degrees like other people collect stamps. Went to a state university. This 3 times the power out of something that is not even 20% the actual mass, meaning the physical space. What are 3 points that would give you that extra power? Like, how will you derive that much power out of such a small footprint?
So normally to benchmark things fairly, we say, let's compare 2 motors with the same power, right? You can make a very powerful Radial machine. It's just going to be very heavy. So we say, okay, let's look at, I don't know, like a 250 horsepower motor, right? That you'd find in your car. A lot of the mass in the electric motor is in this lamination stack that you make for the Radial machine. So maybe the equivalent torque power motor, you might have a 25 kilogram stack of laminations. Now this whole motor is only 12 kilograms. So already you just that lamination stack alone is already double the weight of the entire motor. So the beauty of this yokeless topology is we remove about 80% of that iron. We remove that big yoke holding all the teeth together. We say that's obsolete because of the way the magnetics work in this machine. We combine that with a very effective cooling where we're actually flowing the cooling 100% in contact with all the bits that create heat, which are the copper. Now, as you'll know, because you've driven a lot of sports cars, Radial machines struggle getting the heat out, which is why they can be, you can get 1 or 2 0 to 60 or 0 to 100 kph, and then you have to back off the throttle pedal. The beauty of this technology is the cooling is great, and we use the materials very effectively. So that means that where a Radial machine might be overheating, so you have to enlarge it and oversize it to get that thermal capacity, thermal performance, we can do the opposite. We're going to say, actually, we can shrink it because that repeatable performance is there. We can actually shrink the motor down. So we get those 2 effects really combining together. The really effective topology that gets rid of a lot of the unnecessary materials, a very effective cooling that then enables that repeatable performance and a further shrinking of the technology. And that's really, when it comes down to it, that's where that 3-to-1 ratio is coming from in terms of power density.
Does the effective cool, which if I'm hearing this correctly, that too is a smaller footprint, does it keep the overall motor lower temperature?
Yeah, I mean, again, one of the beauties is if you're on a track, you're going to be running everything hot. But if you're using the motor in normal sort of day-to-day performance, the very effective cooling means that the motor runs extremely cold, and that's of course good for durability. It's good for life because the copper insulation ages a lot less when it's held at a lower temperature. So these things all add together to create a better product.
Okay, so the clear benefits, you've created a much smaller footprint, significantly lighter weight, which is the biggest enemy of an EV. Let's step back a bit. You talked about this being the result of a PhD you did. Where are we sitting right now?
So actually, this is the original beast from the PhD. So this this is literally motor number 1 sitting here, and this doesn't have particularly impressive performance. This is a 20 kilowatt motor. It weighs about 20 kilograms, so it's hit a mighty 1 kilowatt per kilogram, which, believe it or not, back in the day was actually competitive to what, compared to what you'd find in a...
When you say back in the day, when was that?
This was around the sort of 2005, 2006 period was when I was doing my PhD, 2007, 8. So this is, 15 years ago. Now, because of the potential that we saw in that product, not necessarily as a product, but as a technology, that led to the company YASA being spun off from Oxford University back in about 2009. And really, that then enabled us to start developing our first proper products. And we spent probably about 5 or 6 years going from a 1 kilowatt per kilogram product up to maybe about 7 kilowatts per kilogram. And then that led to us winning our first automotive programs where we were being specified on mostly high performance hybrid supercars.
Okay, so let's not jump ahead because you're jumping over a lot of stuff here. It's important, and I think is the fascinating part of your story. So you did your PhD at Oxford, and we're sitting just outside of the Oxford campus now. What's the process when you say us and we? There's a lot of that royal we when you were talking about the technology. At what point did it go from a student creating this thing that looks like something from the movie Short Circuit to you had other people involved and getting investors, I'm assuming?
Yeah, there was a very interesting journey around the 2008, 2009 era when there really weren't many electric cars you could buy. It was after the EV1, it was before Nissan Leaf, before
Leaf and the
Tesla was just sort of coming out with the Roadster, that kind of era. And so it was, as you can imagine, it was very hard to get investors interested in electric vehicle technology because they're just like, what is this market you're talking about? Coupled with that, if you talk to investors about wanting to invest in automotive, back in 2009, this was a market which they saw as very low margin, very commoditized. No one makes any money. In fact, all the tier ones and suppliers have huge trouble in that industry. So the investment community wasn't really very interested. But we managed to persuade an initial investor by saying, well, we could also look at other markets like marine or industrial. And that's what we really did for those first few years, was look for any market that needed an electric motor. We also got to do some fun projects, like we did things like a land speed record vehicle. We started working with Jaguar around 2012 on their CX-75, which was a
beautiful car.
Never went into production.
Yeah, but some good work on that one.
A really important development for us to show that we could make and design a product that would meet automotive standards. So we went and did some durability, and they made track cars, and we really demonstrated the capability of that technology, and that created a great platform to go and win some proper programs that were going to go into some decent volume.
So as we've discussed, my background is technology, and in the U.S., the community outside of, say, Stanford, outside of MIT, a lot of investment there. And there's been a number of companies that have been spun out of both of those universities. Was that the case here? There were investors, angel investors, whatever it was, that saw an interest in you, or was there somebody like a faculty member who's like, you know what, you should go chase these guys because this is something that's interesting?
Yeah, it's a good question. I was always interestingly, in working for a startup. I always loved that. The concept of taking a very embryonic idea out of university and getting the opportunity to mature it. What I didn't anticipate is I get to work on my own startup, so that was a lot of fun. What you're not told is there's an awful lot of graft in developing a startup, and there's an awful lot of periods.
Oh, I could tell you war stories, my friend.
We've all got.
I got 15 years in Silicon Valley. I'd love to compare them between Oxford and Silicon. Well, that's another episode, though.
Yeah, there's a lot of graft. There's a lot of challenges, and there's also a lot of funding rounds. One of the probably I'd say the disadvantages of doing startups in the UK is you typically get 18 months of funding, and they keep your funding rounds as tight and as small as you can.
Yeah,
you have to do it on a lean team. So I guess that teaches you from an early age to keep your team lean, to use your capital very efficiently. It means you can take fairly limited steps and risk.
You went to Oxford under the provision, or the idea was you wanted to get into the startup technology world. Yeah, that was like one of the reasons you wanted to go to Oxford.
Yeah, absolutely. It was always interested in engineering. So I've got some engineers in my family. So I always loved the idea of being an engineer. But I think from a young age, I recognized that there was something quite pioneering that you get in a startup that is harder to recreate in a larger company. I think there's something about that kind of live and die mentality that a startup has, where if you don't get this technology working, there ain't a company here in 6 or 12 months time. And that creates, I think, a pressure, but that necessity, as we know, is the mother of invention. And so that pressure, that necessity, and then actually creates an atmosphere where you're just like, we just got to do it. We've got to solve these problems. And I think in bigger companies, of course, you can create some of that atmosphere, but it's just too easy to give up.
As my old boss used to say, stay hungry, stay foolish.
Yeah, absolutely.
Yeah, so you probably stayed hungry a long time.
A long time.
So at what point was there a team? At what point, what did it go from I to the royal we?
Yeah, so we probably grew at about a rate of 10 people per year for the first 5, 6, 7 years. So we were maybe up to 60, 70 people by the time we got actually specified on our first proper programs, which was about the kind of 2016, 2017.
But when did you first get funding to turn it into a company?
Yeah, so 2009 we started. So in 2009 there was myself and a CEO. So I've always been the CTO at YASA. So we started with some funding. We went and found a facility. We started to develop the very first products, but really we're starting with very little from a blank sheet essentially.
Now the obvious question: are you a car guy?
I love cars. I mean, I would say I've never been probably a petrol head, which is actually my interest. Is the reason why I got into electric motors was because I was interested in electric cars. Very, very.
So you don't got a 190 cars we're sitting at home.
No, sadly not. We are 2 electric car families. So I've had this intrinsic interest in this question. Why are there no electric cars? And of course that question is being answered now because we know why there were no electric cars. Mainly it was just the inertia required and the difficulty of developing this new technology. But since we've had the lithium-ion battery, which is from the 80s, invented actually in Oxford by Professor Goodenough, not too far from here, and then
that's really his name, Goodenough.
That's Goodenough. And
I'm going to fact check you on that. Yeah, that's a good story.
So the Goodenough took the bones of a lithium-ion battery, which was actually invented in the 1970s, but had some sort of safety challenges, invented a better version of the lithium-ion battery in the 80s, and then worked with Sony, and Sony actually pioneered that into a first product for portable electronic devices. But that lithium-ion battery, being probably about double the energy density of lithium metal hydride batteries, really was the game changer for electric vehicles, because for the first time you could make an electric car with about 200-mile range, which was light enough, right? They're still heavier than our vehicles or the internal combustion engine vehicles that we typically drive around in. But what we're going to see over the next 10 years is the lithium-ion battery and its derivatives, they're getting better. Every 5 or 6 years, they're getting lighter and lighter. We're going to see new powertrain technologies, which are going to take weight out of the vehicle. And we're going to start to see electric vehicles becoming lighter and more efficient than the vehicles we drive around today. So we're on that really interesting trajectory of, I think, the industry has embraced electrification somewhat painfully, but they've embraced it.
Literally, I'm going to make you an offer you can't refuse from the governments. That's literally what it was.
Exactly. But there's a strange thing about being single-minded, a bit like we just spoke about in the startup culture. When you've made a decision to go and do something and you say, right, this is our direction, the automotive industry has incredibly deep pockets to invest in battery technology, to invest in powertrain technology. And we're just going to see every year new cars come out with better range, better performance.
So let's step back. Let's go back to 2006, when you are a young student in Oxford and you are hungry and foolish. Probably still foolish now, which is probably a good thing. Was there a process when you looked at this, where you looked at the ecosystem of electrification in the car world, where the way I see it, you could do this, you could be within the motor, the propulsion system, you could be in the energy storage, so dealing with the battery, or you could go further up the food chain, get into the infrastructure, or further up the food chain from there and go to the grid
Yeah.
Was there a decision process for you as an engineer, as someone who wanted to be in the startup
How do I
world?
get involved? Yeah.
Was it like motors or infrastructure? Yeah. Or it was only motors because I like motors?
Well, it's a bizarre story because my project at university, just as I was getting interested in electric cars, was to look at inductive charging. And so I actually developed at the end of my university degree an inductive charger that would charge over a 1 centimeter gap. So just 100 watts. And the dream was
This is in 2006 you did this?
2004 was the end of my degree. And the dream was to dig up all of the roads in the country, especially the motorways, and bury these induction chargers along every motorway in the country so that you could drive your electric vehicle that only had a 50-mile range, but you didn't care because you drove along and you charged as you were driving. Now, the naive part of me didn't realize that digging up roads is actually probably harder than building an entire infrastructure for batteries and electrification. So,
how long does it take to make construction in the UK? It's worse than the mob-run places in New York. I mean, come on.
But my supervisor saw that I had an interest in electric cars, and he was just getting involved in a project to make the world's first hydrogen sports car. So this was with a little niche company called Morgan in the UK. I don't know if you know Morgan Cars.
I built the Morgan from start to finish.
Amazing. So Morgan Cars and my supervisor and a couple of other partners had a project to make a fuel cell based, so hydrogen fuel cell based.
What year? When did this happen?
This project started in about 2006.
Oh, so you're working with Charles?
Yeah, Charles Mauldin.
Charles, great dude, good friend.
He was involved in the project, and essentially we went ahead and built this car. My job in the project, because it funded my PhD, was to go and build the electric motors and some other bits of the car infrastructure. And so
you're a university student heading over to Malvern Link working with Charles, a 100-year-old car company.
Exactly.
I really don't like you very much.
And the beauty about having a very industrial project is every 3 months, you turn up to a meeting and they would say, right, let's look at your project time. You got to build motors in 6 months, Tim. And, PhD student, they like spend a couple of years just sort of gazing into space, thinking about things. So this project really focused the attention on actually making something during the space of the PhD. So, and we had some great industrial help. So had some mechanical designers and some other people helping with the design of the product. But essentially right from the start of the PhD had this idea for this YASA concept. And one of the big goals of the project was to make a very lightweight hydrogen sports car. So of course the project really embraced this technology because we demonstrated that it was a very lightweight technology. So during the course of the project, we made some prototypes, we made a car run. It went to a few shows, it got a lot of interest. But this was just a fantastic project because again, we got to go and visit Morgan every 6 months to see their cars. They designed a special vehicle. It was called Life Car. You can.
Oh, I totally remember the Life Car.
The Life Car. Yeah.
Totally remember the Life Car. Yes, Matthew did work on it.
Oh, did he? Okay, yeah. So that's pretty much the what drove the initial development of the technology. And I remember when they wrote up the report at the end. One of the exploitations of that project was, hey, look, there's some really interesting motor technology that's come out of this, because it was a government-funded project, and very much that was that got the technology to a place where we could start going to the markets, to investors, and say, look, we know the automotive market isn't really ready for electric vehicles, but this technology, we want to get it ready. So essentially, there was no kind of great love of electric motors. There was a love of electric cars to get me engaged in the space. And like I said, some of the people working on this project, some of the people from Morgan and some others, the big ethos behind this car was to make it lightweight. And so that really got me engaged in thinking about lightweight motor technologies. And my supervisor, he pointed me towards Axial Flux. He said, "Hey Tim, go and investigate Axial Flux motors. There's some interesting technology there." Now, so investigating Axial Flux and using, you'll see there are some pretty small segments in here. This actually came out of a desire to use a very special material called soft magnetic composite material, which we could only make in relatively small blocks, maybe about 10 centimeters by 10 centimeters. And that limitation, essentially coupled with the desire to look into axial flux, actually led to these constraints, led to the YASA topology. So again, it's a necessity being mother of invention. And so once we had really worked out how to make these first prototypes, we then were able to do all the analysis behind and show, we've got this real opportunity to make something that's about a third the weight, a third the size.
So let's step back to what we talked about with the different pieces where you can go into the overall ecosystem of electric cars. Was this a function of, well, the inductive charging is great, but the barriers to entry are higher?
Yeah, so my supervisor said to me, look, why don't you take these two technologies, first year of PhD, and figure out what looks more interesting. Take the inductive charging, take the electric modes technology. And I think what became very clear is this life car project was going to be all consuming. It required product, it required making things. So not because of a lack of interest, but just because of a lack of time. The inductive charging concepts got put on the back burner, and all the focus was put onto the motor technology. And actually there have been some very interesting companies working in the inductive charging space. So and actually even just recently I saw people talking about digging up roads and installing inductive chargers. So people are still thinking about these things because there are some interesting opportunities there. But as we said, the infrastructural challenge of digging up roads is extremely
Do you see you're a big stakeholder at this point in the EV world. You're no longer a student. You've created a company. We'll get to how it's been commercialized, but you're a known thing now. Do you feel any pressure, any need to kind of help move things along in the other areas that are more stalled than the actual technology in the cars, like the upmarket stuff, the infrastructure, the grid? Because really those are the big things that are holding things up at this point.
Yeah, I think it's a really good point. The change we've seen in the industry itself is just astonishing because
speed has been incredible.
The speed is incredible. The focus is there. And I think the whole trajectory of most of the OEMs now is very focused on electric vehicles, which I think is fantastic. You're absolutely right though. One of the biggest challenges is going to be the infrastructure challenge. And we see this in the UK, which is getting chargers installed, if you want to get a big solar farm onto the grid, often the biggest limitation is just attaching it to the grid. So this is an area that, the government who owns the grid really need to look at very carefully. Because it would be a great shame if that became the bottleneck. It shouldn't be the bottleneck, but it certainly is.
But wouldn't they look at a guy like you? I mean, here's a guy, not to kind of oversell you, but very few people come to Oxford for a PhD. Even fewer commercialize that PhD. Even fewer make it not just a viable concern, but something that now is leading its technology in the space. Wouldn't the government, whoever, even energy providers come to you and say, here's a guy who successfully transitioned something from very niche to something that's going to be in volume products. Maybe we can have him at least advise in this area. Would that, have you been approached about that?
I mean, that's a very, very kind set of statements. I would say, I am not an expert in infrastructure, and it is hugely complex. But what I do know from my experience is that if you've got passionate people, they can solve. Technology isn't actually only the problem. Normally the problem is just lethargy and a lack of focus. Yeah, I mean, the development of this technology has been really challenging, as I'm sure you can appreciate from your time in tech. But often technical challenges are not the thing that kills startups or small companies. It's often the funding required, or the planning required, or just the desire of
where you are successful.
Yeah. So, but I would certainly hope that the UK government, and it's not just the UK, it's in Europe and the US, that the governments who own the infrastructure, or at least they do in the UK, are really carefully looking at this. because it takes a lot of time, a lot of money.
I've been a big believer, and at least learned this in the tech world, actually. Hire for attitude, train for aptitude.
Oh, so true. Yeah.
Yeah, I mean, it's the only way to kind of go forward now. All of us here at MotoMan are super excited to not only have the podcast back, but for it to be its own show. And there, we look to you for a little assistance. Can you help us grow the show? 2 really easy ways to do that. First and foremost, if you're reaching out via YouTube or other streaming platforms, you click on subscribe, notifications, or more importantly, share these episodes with your friends, especially on Reddit. Now, if you're downloading these episodes, listening via podcast platforms, we'd ask you to rate us. The good stars are wonderful, but leaving a written review would be even better, especially sharing who was your favorite guest. So with that, I am incredibly grateful for your assistance in help growing this. And now, back to the episode. Now let's kind of switch gears here.
Yeah.
This is almost as exciting as the point when I first saw the size of this motor. Who was your really, like, maybe you can't say it, but these motors are in cars people know.
Yeah, I mean, this is obviously
this isn't just pie in the sky.
Yeah, it's. I think it's really exciting when, we've got cars launched on a number of different vehicles. I think that they've been specified on 5 different platforms now. So the volumes are growing, the technology's out there in the hands of many people, and actually.
So should I say it or should you say it?
Well, you can say
it.
Yeah.
This is the motor that's in the SF90 and the 296.
Yeah.
So again, and this is where Tim and I kind of hit it off in California because of both kind of come from the tech world. And I've seen previous Tims, like in the telecom world and the app world. But there are very few people like Tim that create a technology and it ends up in probably one of the most storied marks in the world. I mean, that's a highly unusual thing.
Yeah, I mean, it's strange. When you look back, you need, and anyone that's worked in tech will say this, you need a little bit of luck. And you need a lot.
You need a lot of
luck.
Yeah.
You need some good technology, but a lot of it is about timing.
Yeah.
Because had we started 2 years earlier, we just wouldn't have been able to get funded.
So when did the Ferrari deal come about?
It was about the 2016 timeframe that we seriously started working on that tech, and it got launched to start with in the SF90 in about 2019. So it took about 3 years to go from a concept through to something that we had in niche production, which is pretty fast. So it was a very fast-paced project.
Now the audience at this point is probably like, wait a minute, you met this guy at a Mercedes event. I don't know of any Mercedes these motors are in. So how does Mercedes fit in the picture?
Yeah, so Mercedes is very supportive of us working with our third-party customers because it's a great way of maturing the technology, growing the technology. And
let's be clear, they're more than just a partner.
Yes, so just over 2 years ago, Mercedes acquired YASA, so we're a 100% owned subsidiary. And we saw this as a huge opportunity to combine forces. So I think Mercedes saw in YASA, hey, this is an innovative, fast-paced, small company.
The same exact thing that I do.
And in Mercedes, we see, they are the originator of the automobile. They are probably, if not the most iconic brands, one of the most iconic brands in automotive. But they're not niche. They have the ability to scale. They're an industrial powerhouse. So for us, when we were talking about a deal, we wanted to see something where Mercedes could bring the best out of YASA and we could bring the best out of Mercedes. So it's a crazy partnership where we can do things exceptionally together.
You don't have to say who, but were there other suitors that wanted to buy the company lock, stock, and barrel?
Yeah, we'd never been up for sale, so to speak, because like I say, YASA was started to accelerate electrification. We were created because we want to have an impact on the electric vehicle market. And Mercedes approached us, we didn't approach them, and they proposed something that was really quite unique as a partnership, which, like I said, we weren't looking for this, but we saw it as an opportunity to have the biggest possible impact we could have on the electrification.
Well, what was unique about the proposal besides we want to own the company?
Well, I think you see with a lot of acquisitions, that there's an interest in a certain piece of technology or a certain idea or a certain patent or something. I think what was fascinating about the proposition was they said, look, we love your technology, but we're not buying you for the technology you have today. We want to know what you're going to invent tomorrow, and we want to partner with you and turn that into a volume product. And that, for me personally, was just compelling, because I know what's on our roadmap, and we'll get to talk about this in the future. This technology you're seeing today is 2 generations old. So we've got, if we say yesterday's technology here, today's technology, the stuff we're going to launch with Mercedes in the middle of the decade is another step up. It's mind-blowing. And yet we're already preparing for what's coming after that, which is absolutely astonishing. So we can look from where we've been to where we are to where we're going, and we can plot a roadmap where the technology is pretty much increasing at a rate of roughly, in all aspects, about 20% every year. We're increasing power density. We're increasing volumetric torque density. We're improving efficiency, other aspects of the motor.
So if I'm reading this correctly, one of the interests from your side, not the Mercedes side, you could develop this technology and not have to worry about multiple rounds of funding and being the startup founder anymore.
And also there becomes a point, one of the beautiful things that Mercedes are doing is they've invested in a plant in Berlin where they are going to make hundreds of thousands of these a year. Hundreds of thousands. To do that as a UK startup, you're talking hundreds of millions of investments. And it gets to the point where it doesn't make sense for a startup to do this. Mercedes are world experts at industrializing automotive technology. YASA could have done it, but they wouldn't do it nearly as well as
I'm going to interject here for a minute. What I found, so for the avoidance doubt, we're sitting at your headquarters, just outside of Oxford. Thank you for having me. Fantastic facility. And we just did a tour of the factory floor. I find it fascinating. You actually do the manufacturing here.
Yeah.
And you've got a second shift working, started at 5 p.m.
Yeah.
When I think of manufacturing, I think the Midlands, but I think like Land Rover.
Yeah, sure.
I don't think high-tech stuff like this.
Yeah.
And number 2, I definitely don't think of a second shift starting at 5 p.m.
Yeah. There's a lot of demand for these products, which is great. So, and again, one of the things that I love making stuff. And we've always said from day one, we want to manufacture the products. And it turns out that there's a lot of IPs, a lot of intellectual property, a lot of the patents we've got have been on how to make the machine. And when you looked around the factory, you may have noticed a lot of them have the badge on them, YASA Automation, which is we actually designed and built most of the machines to make the machine. Because actually one of the biggest challenges getting the technology into production was there was no supply base where we could say, we want a winding machine. We want a...
Did that drastically drive up the cost of your startup to have to do that?
Absolutely. So
twofold or tenfold?
Probably tenfold. I would say it was probably 10 times more expensive and substantially more time consuming having to make the machines to make the machine. I was able to make by myself a prototype within 1 year of my PhD. Making a prototype is very easy, but scaling up to make tens of thousands a year, as you've seen we're doing next door, takes a lot of complexity, a lot of thought.
You're testing every motor that comes out of here.
Right. So we have, again, this was a piece of machinery designed in-house by YASA. The only reason is we couldn't afford to spend probably 3 or 4 million pounds that you would need to spend to get someone to design that machine for us. So we fully designed all of the end-of-line capability. So every product, the tens of thousands of motors, they all get tested.
Is that a you thing? Like, are you working on the production engineering, or do you hire specific production engineers, which is a job? But
no, and this isn't really my expertise. So we were very fortunate to find some industry experts from the automotive industry who understood. Some of them had come from the power steering industry, for example, who had automated volume lines to make motors for other parts of not electric vehicles, but just vehicles. And so now I've been involved in some aspects of the productionization and some of the ideas, but it's really, again, you need a blend of skills. You need people that know how to make things in volume in automotive. It's quite a specific skill set. And again, we were very fortunate to hire some really outstanding engineers in that space quite early on the journey, so they could help productionize the product in the right direction.
So if I'm doing the timeline in my head correct, the Ferrari deal predated the Mercedes deal.
Yes.
So they don't own anything in the company. They're just a customer of the company.
Yeah.
So how does that now work moving forward? You are still supplying these motors for the Ferraris, but you're now owned by Mercedes. I would think there would be a conflict of interest. How is that? What is there a do not call list? Is there you cannot sell to this person, but you can work with others? Where are you at now?
Yeah. So Mercedes are very supportive of YASA having production on site. They want YASA to have end-to-end responsibility because I think good engineers learn a lot from the mistakes you make in production. And the production guys say, never design a motor like this, or don't you dare use those tolerances again. So this is a very important feedback loop. And generally the niche kind of sports car customers we're working with, these aren't competitors to the Mercedes brand. And you might even argue that they're additive in some ways or complementary at least. But I think it's a very important part of YASA that we are supplying a number of customers, non-competitive
at this
customers.
point, not just Ferrari. We won't say who. Not just Ferrari.
A number of other customers that maybe may get some media attention in the next few years. Yeah, and I think also it's just a very important way to mature technology. I often get asked how do you deploy technology into the automotive industry, and I've debated this with many people, and I haven't found another way other than in through the top. So, our first serious automotive customer was Koenigsegg. Koenigsegg only needed a couple of hundred motors, but even that was a vital stepping stone in just, going from the hundreds, then into the thousands, then the tens of thousands, and the hundreds of thousands. I've not come across any stories of someone just creating a piece of powertrain technology and putting it straight into the, hundreds of thousands. It just doesn't happen because there are so many things that have to be demonstrated about a technology. You can make it in volume. It's robust.
Did you find Christian or Christian find you?
I can't remember. I think it was a bit of a mutual thing. I think our biz dev was probably chatting. And they found each other. Yeah.
It's kind of, again, my tech world brain is kind of just going crazy with some of the stuff that's happened in a short period of time, if you really think about it. It's, 17 years, 18 years since this thing here.
Yeah, I mean, it feels like quite a long time.
Ferrari, Mercedes, Koenigsegg. There's another one there's a couple of them not mentioning because I saw them in there.
Yeah. I would definitely say there was a huge inflection point around 2016. So we spent 6 or 7 years pretty much, I would say, a bit in the wilderness, really trying to find homes for the technology because the market just wasn't there. And really the key transition happened around the kind of 2016 when we started to get specified on programs so we could build a production line and really carry on with the maturation of the technology. Because you can have the most wonderful technology in the world, but if there is no home for it, if there are no customers that want to make fantastic hybrids or electric cars, you're stuck.
But from what I'm reading now, between the tea leaves of what you've told me, there is a green light from Mercedes to sell this technology to niche car players.
Absolutely.
So like a Koenigsegg, a Ferrari, or somebody like that. Yeah. But you wouldn't see that technology in like a Porsche Cayenne, which would be a direct competitor to a GLE.
Exactly. I mean, there are basically a couple of very clear rules from Mercedes, which is the projects have to be additive from, like, we're doing something interesting with the technology, and they have to be obviously a positive business case. And as long as those two are true, then Mercedes are pretty open, like I said, for us to building the manufacturing in the UK.
And is there a discussion to reach beyond the automotive world? Because you had originally started maybe marine, maybe aviation.
Yeah, so we do some other markets here. Now, out of YASA spun a company called Evolito, which happened before the acquisition. So Evolito is taking this technology into the aerospace market. So that's a completely separate company from YASA. But anything that's non-aerospace, including marine or some industrial, we do here within YASA.
Now, is that company looking for propulsion of aircraft or secondary system power?
Yeah, it's very much focused on propulsion. So
Wow.
it's taking this technology, and I personally spent some of my time working with them, and we've had some fantastic breakthroughs with the technology. Again, this is more than doubling the power density that we see in the latest products today is what we can achieve in aerospace. So a few more composites, slightly more expensive materials, and we can see a massive step up in the technology.
So stepping back, got to ask, are you the patent holder of this? Like Dr. Tim, is he the patent holder of this?
So the technology's got around 150 patents on it now. So there's not, there are a few key patents, but we've very much taken the approach of when we've hit a problem, because we haven't copied anyone, we've been the first to commercialize this technology. When we've had a problem, we've just worked hard to solve the problem, and normally that's yielded patents. So that's the nice thing about being the first to really mature and commercialize the technology. So we've got a pretty broad set of patents, and we're still inventing. So we're still patenting a lot as well, because there's a huge open space.
So some of them are Dr. Tim.
So some of them were invented during my PhD. So a number of them have my name, and others. Many of them have come from the YASA team over the last 10 years. So they've got lots of different names. I've been involved in quite a few of them. But the whole patent portfolio is owned by Mercedes. And so that was part of the value that they saw in YASA, is they've not only got a team that can invent, but they've also got the patent portfolio, which somewhat protects the technology from others getting too close to what we're doing.
Do you see competitors in your space at this point?
I think, interestingly, there's been a huge increase in, so we track the number of patents, for example, in Axial Flux motors just in the last 2 or 3 years. So I would say traditionally we've not really seen too many competitors in the space. I think in the next 3 to 5 years, I think there's going to be a lot more interest and a lot more developments, a lot more patents, a lot more people developing the technology. So what I say to the team at YASA is, you've just got to be fast, because we're not really, we don't look to be a defensive company. We're not particularly litigious or looking to chase after people that have similar technologies, because our motivation is to make the best products and to get there first. So to be quick, that's our motivation. That's our best defense. And like I said, if you look at the speed at which the technology is developing, every year we're looking for 20% plus gains. There's just a remarkable trajectory for the technology. We haven't stopped. We're kind of almost at the early stages of the.
You've been reading books by Jack Welch. That was his. You've been reading books by Jack Welch.
No, what did he say?
Jack Welch, who was the famed CEO of GE.
Okay.
And his whole thing was be first or second in industry or get the hell out.
Yeah.
Meaning be fast.
Yeah. Yeah.
Which I always found fascinating. Okay, so being fast, let's talk about this. You had kind of intimated that there's another generation that's already working on, and a generation beyond that. You're at the germination stage of that. Anything you can share about that? Things we can look forward to? Let's dream together. Sell me the dream, Doctor.
Yeah. Well, I obviously can't say too much, but the power density of the product is getting to absolutely eye-watering stages where, if you compare it to a carbon ceramic brake disc, it's pretty much there. Now that starts to open up whole new games as to where you can put the motors. Maybe instead of having them right in the center, you can start placing them close to the wheels. You can think about the amount of regenerative braking you're doing and really push those limits up, which massively increases things like your track efficiency and your efficiency in real world driving as well. So, and of course, we've got the whole weight down, where if we can take another 50 kilos out the traction system or another 100 kilos out, that cascades to another 100 kilos in the vehicle. So we're really on that trajectory of huge, not just little steps, but big step gains in the propulsion system, big improvements in the architecture where we can place them, and big impacts on the whole vehicle architecture. So we're going to see some fascinating technologies come out. And it's not, of course, just YASA working in this space. The whole ecosystem is looking to say, well, what is the next generation of electric vehicle going to look like? What are the opportunities? Because we're really 10 years into a journey. Automotive has been making cars for 100 years. So I think over the next 10 years, we're going to see some really surprising step changes.
My audience knows this about me. You know, I love tech. Obviously, it's my background. I've always loved tech. The big problem I've had with the transition to EV, I feel like the wrong people have been pushing the wrong incentives, and it's kind of sullied an otherwise promising technology. Like governments coming in with mandates in unrealistic timeframes just screw everything up, and they're not trying to solve the problems they're really trying to solve. Or the problems that they have identified, they're not trying to solve those problems. And I'm listening to what you're telling me. If I'm getting this correct, you don't have to confirm or deny because I know that this is a future product, but the reality is this would be a game changer if you're talking about positioning the motor somewhere else. I would almost think that you guys, Mercedes, you as just YASA, would think you'd need to pull the Elon Musk thing where what made him successful really wasn't the cars. And if we're honest, the cars weren't screwed together very well early on. They weren't particularly great. They were designed to look like an Audi A7 because that's what everybody wanted, an Audi A7. They could have been anything at the time, but they just made them look like a car people wanted. What you're talking about is changing the form factor, and it sounds like it would be more, at least in this second generation, talking about very high performance cars.
Yeah, I mean, again, if we go to why does YASA exist, we're not existing, or we didn't start to, just move the dial a little bit on the automotive industry. We want to have an impact because we love the industry and we love technology. And I think what we're seeing is a whole number of things converge. We're seeing the performance of the motor and the weight come down, the performance go up. We're seeing real openness and desire in the industry to do new things and different things, because otherwise all electric cars can generically be quite similar. They can converge into quite a boring space. So
they'll just be widgets.
Yeah, they're looking for differentiation, and we see in our technology the opportunity not just to differentiate, like I said, at a subsystem or motor level, but have huge impact at an architectural level. And again,
so does that mean you're working with the folks at Mercedes, kind of like Elon did, where I'm not just about the car. I realized to sell the car, I need to have an infrastructure. So he built an infrastructure, and now he's got a second business.
Yeah.
Are you working with the folks, let's call it the M&A group at Mercedes-Benz, where you're going and seeking out technology to get that battery smaller, to make that battery lighter, or I know that they're doing some investment for infrastructure in the U.S. Do they consult you on that? Are you part of that?
Yeah, I mean,
that decision process?
We're really focused on propulsion technologies. That's our game. And we've got our hands full with stuff to do there. So, and we see such an opportunity in that space. So there is, like I say, there's so much innovation going into the current gen of products and the next gen products. There's no shortage of spaces to innovate. And I think they're actually going to have a huge impact at a vehicle level. And that's what we get excited about.
Do you see something like this making its way into like an A-class? A serious production car?
Yeah, I mean, again, the long-term trajectory, we can only ever see kind of about 2 generations ahead of us, because it's too hard to see 10, 15 years into the future. But certainly we're scaling the volumes. We're going from the tens of thousands you see here to the hundreds of thousands. Of course, the dream would be eventually to get into the millions. Why not? But that's a whole another journey to scale the technology to that level. So to start with, we're really focused on the sports car, the high performance space, because that just fits perfectly with the USPs of the technology.
It's more fun.
It's more fun as well. And then, but ultimately, of course, the hope is we want to have a broader impact on the Mercedes portfolio. But this is really too early to tell.
Okay, so let's kind of like look at this from a 30,000 foot level. What are 3 aspects that have made you and YASA successful? If you were to point to 3 things that happened in your career in you developing the technology, What are 3 aspects that led to the success that YASA is today?
So, good question. I think I'd probably say, not in any particular order, I'd say your technology needs a good DNA. We could never have predicted, or we knew this 3-to-1 ratio should be there right from the time of my PhD. I didn't think that we would maintain it over all these years. And so the technology's got a great DNA. I'd say the second thing is we've had to persevere through some really tough, difficult projects and solve some really hard problems. And I'd say that comes down to we've nurtured and mentored a fantastic team with YASA
And I never asked, how big is the overall company people-wise?
Yes, it's about 400 people now. So I'd say about half of that is related to the operational production side of the business and maybe half in the engineering side. And then the third point is that you need some serendipity or some luck, some good fortune. And I would say that the timing, some of the way the market evolved and changed, some of the business relationships, if you combine that, you need a bit of good fortune, you need the team and you need the technology, then I think you've got the opportunity to make a great business.
That last one was particularly honest. And at that, I have to say, thank you for having me.
Thank you.
Really appreciate this. I'm fascinated by the whole story and very much looking forward to seeing this in other cars besides some of the Italians. With that, you've never been on the show before. And what I like to do at the end of these episodes is turn the episodes around to the audience and have them give you feedback. So if you were talking to the audience, and I'm going to preface this by saying they are brutally honest, what kind of feedback would you want from them about YASA, where you're going, what they want to see? What would you want to hear about?
Yeah, I mean, obviously we're always fascinated to know what do you guys think about the industry? How can we make electric cars more engaging? If you were to take the DNA of this technology, what should we be focusing on next? So love to hear your feedback.
That is a very good question. And this is the boss. Like, the man has patents and he founded the company and he sold the company to Mercedes. So he is the boss. He can make it happen. Comments below or via our social media, MotoMan TV, all one word, MotoMan TV, all one word, Facebook, Twitter, and Instagram. And with that, if you found this discussion fascinating, I shot, when I first met Tim, the car, or at least the concept car that would showcase these motors, which I'm guessing was a concept of what the real thing is going to be. That was the Vision 111 concept, which was orange. Very unusual color.
Was it?
But definitely a good carrying case for your motors. You can see that episode here. Until I see you in the next episode, bis später.